Hello everyone. GM. My name is Cindy Kamau. I'm a blockchain developer and I love anything and everything about blockchain infrastructure and protocol development. And I'm also a developer relations lead. I'm working at the developer relations department. And so I'm a developer advocate and I love teaching everything about Web3 in a very simple but digestible format. So if you don't know me, welcome to my channel. I'm the queen of analogies. So we'll be using analogies so much in this YouTube series on building on Starknet, whereby we'll be using stories, relatable stories, to be able to connect them with blockchain concepts, which seem otherwise very abstract. And so I hope you'll be able to enjoy this insightful session. The first session is on an introduction to blockchain. So we'll be talking about what is blockchain, why should you care about blockchain, and we'll be using an analogy to describe the fundamental concepts of a blockchain structure. I hope you'll be able to learn something from this, and I'll hope through this you'll be able to have an interest on building on Starknet. Thank you so much, and let's start. So, as I talked about, my name is Cindy Kamau. I'm a blockchain developer. I'm a developer advocate. My Twitter account is at Cindy Kamau, and there I accidentally lost my Twitter account, so I've started again. But you'll be seeing I'll be posting a lot of more technical information, a lot of insights in the space. So kindly please follow me. You know how it is. So yeah. So as we continue, we'll be talking about what is blockchain, why do we really need blockchain, and as I said earlier on, we'll be using an analogy to discuss the foundations of a blockchain. So if I were to explain blockchain in the simplest terms possible, I think of blockchain as a very global Google Doc. Mostly we use Google a lot, so we'll be using Google um, as our analogy, actually. So we use Google a lot. We have so many Google offerings. We have Google Drive, we have Gmail, we have Google Docs, we have Google Photos. So when I think of blockchain, the first concept that comes to my mind is a very global Google Doc. You see the way we normally, you have so many people having access to the same Google Doc, and they can make edits, and they can do this, and they can do that. That's what I see blockchain as, a very global blockchain where everyone has the same copy of the same document, right? And in case any document is made real time, all the changes are made across all the people who have access to this document in real time. That's how I would very simply explain blockchain. I mean, I don't know, we always talk about, oh, it's a public ledger, blah, 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 blah. I don't know, it's like a public ledger, but imagine you have like a Google Doc, and during the time and the version history of the doc, you can see everyone who made an edit to this document real time. So the changes, it's like it's immutable, right? Now, once you make a change, we can be able to know at this time and at this day, you made a change to this document, and everyone has the same copy, so you can't like deny, oh, I didn't make a change to the doc or something. Yeah, so that's how I could easily very simply explain blockchain, like a very global shared Google Doc. Okay. Yeah. Yeah, so I'll be using a character called Cindy. Obviously, I love myself so much, so I'll be using myself as a character. So I use Google a lot, right? So I have my Google Photos, I have my Gmail, I have my Google Drive, having so many documents, so many folders in there. I use almost all the Google offerings, even Google Maps, right? So what if we woke up one day and just Google decided to like shut down? Right? So they decide, when you try to like enter your email, there's nothing such as an email, such as like Gmail, right? There's nothing there. You don't have your accounts there. When you try to enter your Google Photos, you don't have like all the photos, and the way Google Photos has like a history of so many years, depending on when you started like saving your photos on Google Photos, you have like a history. It's like a digital history of your timeline, and all your photos, all your images are in Google Photos, right? So you wake up one day and everything is just poof, gone. The same as, I would say, let's say Instagram or TikTok, etc. Everywhere where you upload some content, even YouTube, right? We upload content there daily. Uh, if they decide to shut down, essentially there's nothing we can do, right? Because I mean, we're not the ones who are hosting these videos. Have you ever asked yourself, let's say if you upload even an image to Instagram, where is it hosted essentially, and etc etc etc. So when you look at it in a deep manner, you get to realize that most of these normal applications that we use on a day-to-day basis, we don't even have like a lot of access to them, if I can say so, right? So if they decide to shut down at any one point in time, there's nothing we can do. If we wake up one day and let's say Instagram decides to revoke your account, and let's say they say, oh, you are a scammer, or maybe you're not following the rules and preferences and whatever, there's nothing really you can do about it, right? And to show you how important it is to understand this is, I had my old Twitter account, right? And then some hacker was able to access it, and they changed everything. They changed like the email address, they changed the password before I could even gain access to it. So by the time I was receiving an email from X that my email address has changed and my username has changed, etc etc, there's nothing much they could do, right? Because they were like, okay, because of due to rules, like we can't due to privacy, we can't be able to like restore your account, we can't be able to do this. So I had to start again I had to start over. That doesn't mean I did anything wrong. It's just, what can I do, right? So now let's go back to Google. Now imagine the same happens to you. So you wake up one day and then someone just accesses your Google account and they have everything, and or maybe Google decides, we don't like you, let's just shut you down, right? So what exactly can you do in such a situation, right? So Cindy, back to our character Cindy. Cindy woke up one day and all her photos are gone. All of them are gone. Google, they decided to shut down. Maybe they decided business is not doing as good as it was used to. So let's just shut it down. So when you try to, so Cindy now tried to analyze what went wrong, right? And so she realized, essentially, Google is a centralized service. What do we mean by centralized? All the servers, everything is in one company, right? So all the data, all the warehouses, etc., etc., it is hosted under one company, right? So if anything were to happen to the main servers at Google, that's just one point of failure. That's what I call one point of failure, right? So essentially, all these centralized entities. And when we talk about centralization, normally we ask ourselves, what are they really doing with our data? I mean, we don't know that there are those data privacy policies that we normally click, I understand, before even reading through whatever blah 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 blah, blah they say, right? But really, when we ask ourselves, what do they do with our data? Right? Even in Instagram, when you post all your photos, etc, etc, etc. So what do they really do with my data? What if they're selling people's data, right? What if Google is selling your data? That's why when you like when you're just thinking of something, all of a sudden you're seeing specialized or targeted ads in that, and it's not like they asked for permission. What they just did was sent a very vague and it normally has like a very hard English privacy policy, etc etc, that we normally click, I understand, without going through all this, right? So simply put, Google is the landlord, just like we normally have rented houses or apartments. So it's the landlord. We are just renting out their services. If the landlord decides today that they want to shut down the entire apartment, there's nothing you can do. Despite having all your things in the apartment, or having stayed there for, let's say, 10, 15 years, there's nothing much you can do because it's not essentially your property, right? So we normally use this suite of tools, but essentially it's like we're renting some features that we're using for there, right? It's not like we're owning most of these things. So yeah, in this world, Google collapsed. So what happened? Now, Cindy had an epiphany. Of course, she had an epiphany. She's a very smart lady. So she has an idea. What if we decide to create our own Google platform, but now there's no central company like an LLC or something that is managing this platform? It's the community. right? So Cindy gets people from the community, the members come, and then they have like a town hall, and then she pitches and proposes the idea to the community, right? That everyone is complaining, okay, Google is down. So what can we do? There's nothing. So what if we create and design our own platform, our own Google platform, but now it's owned by the community, right? So what do we mean by owned by the community? First of all, the servers, they're not stored in one place, right? The servers are sort of everywhere. So we'll get to see how this looks like, but let's look at this case study. What if Google was decentralized in itself? How would it look like, right? How would they design a decentralized Google, essentially? So how would they do that? The first thing is, obviously, they would have to host it themselves. What do I mean by hosting? Obviously, having such a platform, you need to store it somewhere, right? Even when you access a website, like when you, let's say you access Google or Chrome, or you go to your favorite website, right? It has to be hosted somewhere. So they decide to set up their own servers. So everyone in the community decides to run their own server, which will be used to host the entire platform, store the data, etc., etc. Right? So everyone decides to run the servers, right? So now in the Web3 space, these servers are what we call nodes. So when you hear nodes, just think of them simply as servers, right? So how do they work? You can decide to like run this server using your phone. Like when Bitcoin was starting and people used to mine it with their phones, like you can have a laptop, you can have a server. And if you don't have, example, you can use cloud, right? So you can even be able to like run nodes using the cloud infrastructure if you don't have like the physical infrastructure. So what would you what happens when we say you run a node? You download the software which is needed to run the network that you want, and then you start running it, and then so you make sure all the requirements which are needed. If this network, let's say if Google needs, let's say 8 gigs of RAM, let's say it needs like 2 terabytes of storage per every node, whatever, right? So you make sure you have all the requirements you need, and then you start running the node, right? And normally when we talk about this, we have like something we technically call like a peer-to-peer network, right? Because if you have a node, my neighbor has a node, my other neighbor has a node, they sort of start intercommunicating with each other, and that's what we call a peer-to-peer network, right? So back to Google. So the first step, what have we done? We've decided to build our own platform from scratch. So Google. So the first thing is we need to find the servers. So everyone has decided to run their own server in the community, and they've done so. So that's a check. So that's the first thing that you do. You need like a peer-to-peer network, right? So everyone starts setting up the network. Thanks to Cindy. Now, what offerings do we have on this Google? Obviously, we have our Google Doc, we have our Google Drive, and we have our Gmail. Let's say we have those three main offerings. So we have a Google Doc, we have our Gmail, and then we have our what? We have our Google Drive, right? So like you said, remember, we said this platform of ours, we're going to make it look like a very global Google Doc. So first of all, everyone has access to the copy of this Google Doc. So what is this work of the Google Doc? The Google Doc is let's call it like a ledger. You know the way a ledger works, right? So its work is to record everything that is happening within the network. Okay, so now the first problem starts, okay, let's say challenge. The first challenge arises here, right? So now we have this Google Doc. Let's say 20 people joined in and created the Google servers. Everyone is running their own server. And now we have received every person, we have received a copy of this Google Doc, and it's blank. So who will be the first person to write into it? Okay, so now that's the first challenge we get, because we're now wondering, what if you want to write on this Google Doc? I want to write on this Google Doc. Let's say I want to write that at 10 p.m. this and this happened, or at 5 p.m. This and this person uploaded their photos to Google Photos. At this and this time, this one sent an email. At this and this time. So who starts? And obviously with such a question, it may be a bit difficult normally to decide who's going to be the first one to write on the Google Doc. So how is this solved in the blockchain aspect? We introduce something we call consensus mechanisms. What are these consensus mechanisms? So the first consensus mechanism would be proof of work, of which we're going to see it on a practical level. So what is this proof of work? So this proof of work is everyone is running a server, right? So we sort of design an algorithm that you need to solve some very difficult mathematical equation, if we can call it that. And the first person to solve that puzzle is the one who will earn the right to start writing on the Google Doc. That's what we call a proof of work mechanism, right? So all these servers, it's not you as a person, it's now the nodes that you're running, right? They are all competing against each other, because all these nodes, they're processing things we call transactions, right? And we want to know which will be the first node to write on our Google Doc, right? So they are starting to solve very complex mathematical equations, and the first to solve it earns the right to add to the Google Doc. Okay, so that's what we call proof of work, and that's what works in the Bitcoin ecosystem, right? That's why even the nodes which are in the Bitcoin ecosystem are called miners, because essentially they're mining Bitcoin, right? So we decide, well, let's start with this proof of work. So essentially, these nodes compete, and then the first node which solves the puzzle earns the right to write on our Google Doc. But now an issue arises, right? Because let's say you have a very powerful computer, right? And for me, I only have a phone. And we've been given a puzzle, and you have the necessary computation to be able to solve it very fast, more than I do. What happens there? It means you'll be the one who will always be right most of the time, right? You'll be the first to very quickly solve this mathematical equation. So meaning you'll be the one who will be writing in this Google Doc a lot. Yeah. So why is that important? Because anyone could be asking, okay, so they write in the Google Doc. Okay, so what? Now, I imagine we need to incentivize people to run these servers, these nodes, these Google servers, right? Because I mean, I'm using electricity. I have to use electricity. I mean, my node has to be live most of the time. So I need to have what? I need to have internet. So what am I gaining from running this, right? So let's say if you add something to the Google Doc, of which you'll be able to connect later on how this works, your node earns something for you, right? So every time you add something to the Google Doc, because that means you've processed some sort of a messages. Let's say you've said, okay, Liz has sent this to an email using Google Gmail, right? So let's process it, confirm that Liz and this is the person, what have they called it? Let's say John. Liz and John, they're both true people, and the message is valid. It, let's say, does not contain very bad stuff. So it's not a spam. Let's say it's not a spam email. So your node or your server, essentially, it's the one which is running all those checks to confirm and see that this email is valid. So it processes that email, and then it adds it to a Google Doc that during at 10 p.m. Liz sent John an email, right? So you earn something from it, right? So you can feel the frustration, because if I have a very powerful computer and you have just a simple phone, and we're both working to solve the same mathematical equations, but you're able to solve it faster because you have a much powerful computer than I do. That means you're earning more money than I do, which means I'm running at a loss, right? So even when it comes to now Bitcoin, that is one of the challenges. That was one of the challenges of the Bitcoin ecosystem, because of the proof of work ecosystem, whereby you find that a lot of energy consumption is being used, because what will happen, everyone will scramble to look for the best nodes. So you'll have like an aggregation of mining farms. Like there's something we call like mining farms in the Bitcoin ecosystem, right? So imagine you're now trying to join in as a miner right now, and we have people who have mining farms, huge commercial mining farms, right? And you're just coming in and you have your simple, just like a very simple server, or even a phone, because essentially you can be able to mine using a phone. But now the issue is, by the time you even get proper returns, a lot of time has been used. Okay, so that's one of the challenges this community faced, because now the members of the community started complaining, no, I'm still running the same nodes these people are running. Why is it that I'm earning, let's say, $10 and this person is earning $100 and we're still doing the same thing? No. So now the second aspect of the consensus mechanism, which was now produced, is the proof of stake, right, which is a bit fairer. So how does proof of stake work? So everyone who's running a server, they stake some amount, like you lock some funds. Let's say we decide if you want to run a node, you have to lock, let's say, $50, right? So everyone who's running a network, a node, sorry, in this community, they all decide to lock away some $50. Everyone. And then now the system randomly picks the next person who will add to the Google Doc. So it makes it a bit fairer, right? But now I'm saying a bit because if you still lock more funds than another person, you will have higher chances of being chosen as the next person to add on to the Google Doc, right? So they still amount to financial muscle, both of them, right? It's just that with the proof of work, it's more, I could say it's not fair, right? Because it depends on your muscle to buy really heavy computational nodes, miners, right? But now with the proof of stake, and this one is introduced now to the Ethereum network, right? So with the proof of stake, everyone in this community decides we're going to lock down $50, but we'll still leave an allowance that if you feel very lucky, if you feel that you're very generous, you can stake, let's say, $100, whatever you want, right? So everyone stakes, and then the system just randomly picks whoever will be able to add next onto the Google Doc. And so that person who adds next onto the Google Doc earns the fee, which was used to process all those emails, etc., right? Now, that's proof of stake. So proof of work, Bitcoin, proof of stake, Ethereum. The third one, which is very interesting, is and it works in the Solana ecosystem, is what we call proof of history. So how does proof of history work? With proof of history, this is all about timestamps. So if you, let's say we have like a waiting bay. Let's say we have a waiting bay of all the people who want to add all the information to Google Doc, right? So the first person, it's like first come, first served, right? With proof of history. So if your transaction came in at, let's say, 10 p.m., you'll be the first one. If the person's 10:20, 10:15, whatever, based on the timestamps, that's the order in which all these things are included to our Google Doc. And I'll connect to what the Google Doc means in terms of blockchain, right? So that's what happens in Solana with the proof of history. So there's not really a lot of politics, if I can call politics. It's just whoever comes first, you get served first, right? So I could say those are some of there's still others. There's still other consensus mechanisms, like I think delegated Byzantine fault tolerance. I think if I'm not wrong, but yeah. So those, I could say, those are the main consensus mechanisms, with the proof of work and the proof of stake. And then now we have like the delegated proof of stake, and then we have now the proof of history for Solana. So yeah, but I could say those are the two. Those are like the backbone of consensus mechanisms, right? So now after they do so, they decide, okay, So we now have a mechanism. So for you, they decided on proof of stake, right? Because the first step, the proof of work, everyone complained that the earnings are not fair. Okay, so with the proof of stake, everyone is staking some amount, and by staking we mean you lock that amount. And if you decide to misbehave, your money is eaten, all of it. Like your money is eaten, all of it, right? So that ensures that everyone is acting in the best interests of the platform, of the initiative, right? No one is coming in and they want to like act maliciously. So now that's a problem that's solved. We have proof of stake, right? So that's the first step. So in any blockchain system, you'll see they'll have to consider such scenarios. So the first step which is solved is consensus, right? Now this is what we were talking about. Okay, so obviously not everyone who's coming in, just because it's a community, not everyone who's coming in may be having like good intentions. There's maybe someone who wants to come in and starts running the server, and then the copy that they receive, they decide to like maybe hack into people's accounts, trail them, maybe sell data. Not everyone is coming in with good intentions. And remember, there's no central authority, right? There's no way you can, there's no like central authority and anything. Everyone is on the same level. That's why it's a peer-to-peer network. So how do we ensure that despite the fact that we may have malicious people inside our system, the system is still up and running and is in good standing? So how do we ensure that no one will come and overtake the entire system where everyone is locked out of their Google account and you have to pay money for your files to be, for your account to be decrypted, right? So now that's something we technically call Byzantine fault tolerance. If you want, you can go and read more about how blockchain ecosystems, or rather blockchain infrastructure, they design BFT principles, right? So when technically we call nodes which act maliciously Byzantine nodes. So essentially, we are trying to create a system where even if we have faulty nodes within our system, the system is still up and running and is in good standing and is not anyway compromised, right? That's what we call Byzantine fault tolerance, that we're able to tolerate any faulty nodes in our system. That's what we mean by Byzantine fault tolerance, right? So to give you a quick recap of how we started, Google is down. We've decided to create our own Google. The first step, everyone starts running the Google servers. The next step, okay, we have this Google Doc which will be able to help us know and track down everything which is happening within the platform. But who will be the first person to write on it? That's when we introduced what? We introduced the consensus mechanisms. We started with proof of work, and then we realized with proof of work, provided you have the greater computational machine, you earn more than someone who's, let's say, mining using a phone. So we decided to migrate from proof of work to proof of stake, whereby with proof of stake, everyone is staking some amount. Remember, there's like a minimal level amount, but if you want, if you feel generous, you can be able to stake more. Right? So right now we have the proof of stake, right? And then we decided, we realized we have another challenge. What if someone comes in and they are malicious actors? They want to overtake the system. They want to do something bad with our system, right? Maybe they want to introduce like malware or whatever. So we now introduced a concept called Byzantine fault tolerance, right? Where we are able, since it's a peer-to-peer system, we're able to tolerate even the bad actors in our system, to a point where they don't have enough, if I can say, they don't have like enough leverage to be able to overtake the entire system, because we've designed our system knowing that there will always be bad actors, right? So that's the Byzantine fault tolerance. Okay, so the next step, remember, we've solved two things so far, right? Now, so everyone is happy. Our Google platform is continuing very nicely. I can now be able to access my Google photos. But wait, I remember that everyone has a copy of everything in the Google platform, right? So including if I have my own account of Google Photos and I upload my accounts there, does that mean that everyone with a copy who's hosting all the photos in my Google account, they can be able to access them? Now that's it's another concern, because the community will be like, okay, so I don't want my photos to be online, right? I don't want my details to be online. I don't want anyone to access my Google Drive and see that, okay, so this person has this and this and this folder. What if I have sensitive work documents inside there, right? So that's where we introduce the concept of cryptography in blockchain, because blockchain is all about security, and so we have transparency, but we still have privacy. So they sort of work hand in hand, right? So that's where hashing comes in. Just a sec. Right. So, how are we going to ensure, since everyone is uploading photos in the same network, right? So, how will we ensure that Cindy's photos all have vacation photos, if she has, let's say, some thirst traps, whatever photos she has, right? They are secure, but they're still within the same network. That's where cryptography comes in. So, we have a concept we call hashing, right? So how does hashing work? Imagine now in our Google Photos, right? If I take a picture with my phone and it uploads to the to my Google Photos, right? What happens is we create like a unique fingerprint. I could call it like a unique code. Let's just call it a unique code, right? Like a QR code. Let's just say a QR code for easier understanding. So every photo that I take has its own unique QR code, and this is the QR code that is stored, right? So there's evidence that I've uploaded some photos to what? There's evidence I've uploaded some photos to my Google Photos, right? But it's the QR code that is stored, right? It's not really the photo, it's the QR code. And I mean, anyone can ask this question. Okay, so what if someone reverse engineers this QR code and sees the photo which is representing it? No. So the way hashing works, especially in cryptography, it's one way. So you can create a hash, or let's say we can create a QR code out of this photo, but I cannot use this QR code to reverse engineer and get the photo, right? So I can create a QR code for a photo, but I cannot use this QR code to reverse engineer it and get my photo back. Okay, right. And it's deterministic, if I can call it. I hope I've used the right term. It's deterministic. What do I mean by deterministic? As long as I have this photo of mine, let's say I took a picture right now and it's 5 p.m., whatever, as long as I have this photo, I will always have the same QR code. Okay, so how do you create this QR code? Let's imagine you have a software, right? So you pass your image through the software and then it generates a QR code for you. The same happens in blockchain. We have those encryption algorithms. So you pass an input through the algorithm and then it generates the hash for you. Okay, and the hash is always like a unique fixed number of digits. Example, you can even share an entire book, but when you hash it, it will always be like a fixed number of digits, right? But we can tackle that at a deeper level later on. For now, I want you to understand, how do we secure or everyone who's adding it photos, but we want, because of transparency, we want to audit, and let's say auditing, right? We want to say this person uploaded some photo at this and this time at our Google, remember the global Google Doc, right? So we say this, they uploaded some at this and this time, but we don't want to show what the nitty-gritties, like we don't want, because of privacy, we don't want to show which photo exactly or what exactly did they upload. It's just what we want to record that some sort of transaction was done. So that's how the transparency and privacy work hand in hand, on which is a very ingenious way. Okay, so we use that hashing mechanism. And how does it work? First of all, remember, provided you have okay, it is one way. right? That's the first thing you need to remember, that you can create a QR code or a hash out of the Google photo, right? But you cannot use this hash to reverse engineer and get the photo which is being represented by the hash. Okay, it's one way. The other way means it's deterministic. If you have the same photo, you will always produce the same hash, right? Another thing, if you decide to change even something small out of this photo, okay? Let's say you've taken a photo and then you start applying effects, you start maybe using AI to sort of change it somewhere. That's when the hash changes. Why is that important? Because if you've recorded something and then someone tries to alter, they'll come up with a different hash, right? So that means they don't have what we have recorded here. You see? So because of to be able to allow total transparency, if you decide to change even anything, just anything, even with the recording of the Google Doc, so hashes are very important, okay? Because if, let's say I record, this person added a Google photo just right now, right? Then now someone tries to tamper, then we create a hash representing that message. Okay? Then someone tries to tamper because let's say they want to erase. Let's say they were doing something fishy with our community platform and they try to erase. The thing is now, the hash of that same action that they're trying to do, if it's erasing, it will now be different. So it will not represent the copy of everyone's copy. Everyone has a copy of the same hash. Remember, you always have a copy of everything. So if I say, let's say, okay, X sent an email to Y at this and this time, and then the hash is 12. Let's just say the hash is 12. And then someone tries to tamper and let's say reverse and say, like, X did not send this email to Y. Of course, they'll have a different hash, right? So they'll have, let's say, 15. But now the issue is, and this is why blockchain is a safe system, the issue is everyone has a copy of this transaction, right? And they all have a copy of the hash and they know it's 12. So if you try to come up with another copy and then you say, okay, the hash is 15, obviously these nodes will look on themselves and they're like, okay, but we have 12. Where did you get 15 from? And so they discover you're malicious, they kick you out, right? So that's how it happens. So this is now another problem they've solved, whereby we are having people publicly running and hosting data for people, but in a way that it's still private, right? So you still can't be able to access the specifics of someone's data, but there's a record of it in case anything, or any changes are made to it, right? So during using cryptography, there's a lot deep into cryptography. So using these schemes, that's how you're able to align transparency with privacy, okay, which is very ingenious. So to do a recap again, where did we start? We started with nodes, right? So everyone is running the community server over Google. That's nodes, the first step. The second step is we decided who is going to be writing on the Google Doc, because we decided this Google Doc, it actually represents the state of the blockchain. So if in case someone sends an email to someone, because remember all these Google platforms, let's say Google Gmail, let's say Google Photos, let's say Google Drive, they're being ranked by the community. So we want some way to be able to account to everything. So we decide Google Doc is where we're going to record all the changes which are being made to the entire Google suite of tools, right? So who will be the first one? So we started with proof of work, we realized it's not working, and then we went to proof of stake. So we decided everyone who is running a Google server will stake some amount, and then they will stake an amount, and then we'll be randomly choosing, like let's say a lottery, we'll be randomly choosing who will go next to add their detail, to add maybe some recordings, to maybe log some recordings to the Google Doc, right? After we did so, we realized not everyone will be coming in for the good of the network. So how will we be able to cope and sort of tolerate all these malicious people, but still ensure that the system is up and running always, despite the fact that we still have malicious people within the system? That's why we introduce something we call Byzantine fault tolerance, right? And then now we don't know anyone accessing our photos, right? So how do we do so? That's where we introduce cryptography. So that's where hashing comes in, whereby if I am uploading something, it is a unique fingerprint of it which is being stored and recorded, and in case anyone tries to tamper with anything, they will get another fingerprint, not mine, because I have the original. So we're able to know which is the original, which is fake. Because if I come up with an image, let's say, and let's say, if you have your own document, and then I have my own document, which is a fake, and then we try and send it to the same algorithm which is producing the hashes, and it is seen that mine is producing the exact hash that is in the blockchain, and yours is producing a different one, then we will know yours is fake, right? So in a way, we are able to balance transparency and privacy using cryptography. Okay, yeah. So so far we've been able to solve these challenges. Okay, so what is the next challenge? People, obviously we want people to store their things, right? So we have a Google Drive, we have our Google Photos. Now there comes a challenge. How does our Google Drive work? You're given a cap. Let's say you're given, like, let's say 1 terabyte of storage or 30 GB of storage as a free package, right? And then now you're told, you're given normal with how Google works, you're given like terms and conditions, and you're like, if you exceed, if you exceed 30 gigabytes of your Google Drive, you will not be able to access your things. You'll need to upgrade your storage to, let's say, something bigger, and you'll need to pay for it. But now remember, we have a community version. Everyone, remember, what did we say? We said everyone is running some nodes, and let's say everyone has 1 terabyte of storage in the servers that they are running, right? So we have a pooled storage system for everyone in the community. But now, how are we able to ensure that nobody will come in and then they'll decide, okay, I mean, I have this storage, so they decide to store all the cat videos and all the movies, and it's terabytes and terabytes and terabytes and terabytes of storage, which they have uploaded to the to our shared Google Drive, right? And then now you're coming in and you have important documents, and the space is like almost done because some joker decided to upload all the cat videos that they have, and it's terabytes of storage, right? So that's where the concept of gas fees came from. So when you always hear like gas fees, gas fees, gas fees in the M3 space, just always be thinking about that fee you will pay to upgrade or to store something. Even when you're hosting something, let's say you're using like normal in web development, you'll have like the normal hosting services, like you have example Digital Ocean, or you have like AWS. But for the normal day-to-day person, let's just say when your Google Drive, you're given like a small portion, right? But if you use it, you need to now pay for additional space, right? Even with people who use Apple, like the iCloud storage, right? So you have some free version, and then if it's over, you start paying to get extra. So that's the same thing. So the blockchain space, they realized, what if someone wrote like some code which is running and running and running and running, and it is using all the computational aspect of the blockchain, and so like the network is now down because it's running infinitely, right? It's running infinitely. So what do you do about it? That's how we introduce the concept of gas fees. So any transaction that you perform which needs to be in this blockchain, you have to pay. Example, if I want to upload a picture to my Google Photos, I'll pay something small. Let's say I'll pay like 50 cents, right? Now remember, when we were talking about miners getting some miners fee, like the nodes, when we were saying if they process a transaction they get some fee, right? So where do they get these fees from? This is from the gas fees, okay? So if I want to upload something to Google Photos and then I'm like, okay, pay 50 cents to maintain the network, and so I decide I'll pay, right? Now the parser, the server, the node which will process this transaction and ensure that my photo is uploaded to Google Photos, and the record of me uploading my photos to Google Photos is recorded on our global Google Doc, receives some portion of that money, right? So they will receive that gas fee. So you see why it was important to do proof of stake, because imagine if you're using a phone and there's someone with a very powerful, let's say like an M4 MacBook, right? And so they're able to solve all these computations very quickly, and so they're able to score those gas fees. So by the time your phone is getting one mathematical computation right, they've gotten like 100, right? So you see how fair that it wasn't good to the, like, it's not fair. It's not like a fair economy model, right? That's why we have proof of stake. So those gas fees that you pay, they go to the people who like to the miners, right? Yeah. So you pay for storage. So you want us to store your Google Photos, you pay for storage. That's how gas fees work, right? So even when you start writing smart contracts, when you want to like once your smart contract needs to like execute or it needs to store something, you want to store something through the blockchain, you'll need to pay some fee, the gas fees for it. Okay. So now another challenge that came up. So we have a system, everyone is directly writing to the Google Doc, right? But now this process is quite slow and tedious, because by the time you let's say we have 500 people who need to write the transactions to this Google Doc, and we've decided it's proof of stake, and so it's now randomly, and the process is taking some bit of time, right? So how can we make this faster, right? Make this faster, because it's very slow. Okay, so what happens is Cindy decides to come up with a very faster system, which is like a Gmail. Let's say Gmail, okay? And you'll see Gmail connects to the concepts of layer twos when you hear about layer twos in the ecosystem. So how does this work? Instead of directly writing to the doc any, let's say, transaction that you want, etc, you send emails and they contain the message that you want to be uploaded to the Google Doc, whether it's like a recording, whether it's like a log, etc, right? And then all these emails are bundled up using Gmail, right? So they're bundled up and then they're sent to the Google Doc as a batch. So if we have 500 people and they'll send emails, etc, and they're like, okay, during this and this time I want to send, let's say I want to send money. I want to send money to this and this person, because it's a sustainable economy. Already people are earning using already people who are running the network using the nodes, they are earning, right? So what comes next? They're like, okay, so we'll be sending each other money. I do believe you understand this when we use money, right? Because in the concept of transactions is any data that changes the state of the blockchain. Okay, so what is some of the data? Let's say we want to send money, right? And I want to send money to okay, Cindy wants to send money to, let's say, who? They want to send money to John. Okay, but we need a faster way to be able to process all these transactions, because she's not the only one who's processing the transactions. Okay, so we decide we'll use Gmail. I mean, we are a community. Everyone has an email address. Okay, everyone has an account. Everyone has an email address. If you don't have an account, you do what? You create an account, right? It's the same with blockchain. That's why we have wallets. So you just create an account and then you now start sending money from one person to another. But what happens behind the scenes? That's what you'll be looking at. Okay, so let's look at that. But the concept of Gmail is to talk about layer twos and how they make the system to be faster, because they're built on top of Ethereum. Example, Starknet. okay, and it bundles up and it makes the processing of transactions to be very fast, and then now they're settled where? In Ethereum. Just like how we say, do bundle up all these emails and then you make sure they are added where? They're added to the Google Doc. That's the finality stage. So where they're settled on Ethereum, on the Ethereum layer. Okay, so that's the whole concept of why L2s are there, right? So how does that happen? So let's now connect how this whole concept of Gmail works with blockchain so that you're not confused. Okay, so what does Cindy do? Cindy opens Gmail, which is like a wallet address, right? That's similar to her accessing her blockchain wallet. Okay, so she types in the address of the recipient. Who is receiving this money? Let's say I want to send like 10 tokens, right? Who is receiving this money? The recipient, the John's email address, right? In blockchain, now that's similar to taking the recipient's wallet address and pasting it, okay? And then she types a message in the email, send 5 tokens. Now this message is what we talk about, sorry. Yes, this message is now what we call a transaction, okay? Because it will change the state of the blockchain. What do I mean by change the state of a blockchain? If Cindy had 50 tokens and John had 20 tokens, and then Cindy sends a message, send 5 tokens to John. Wait, I've said Cindy has 50 tokens, John has 20, right? So Cindy decides send 5 tokens to John. So it will remain 45 tokens from Cindy and 25 tokens from John. So that's the state has changed, right? So she sends a message, send 5 tokens. So we create a transaction and the amount is 5 tokens, okay? Now she clicks send. What is different? For us to be able to know that it's Cindy herself who's sending this money, right? We need to ascertain that it's her. And how do we do so? We tell her, okay, maybe type in a special password. Okay, so this is what happens when you're trying to send a transaction to blockchain. We have something we call a private and a public key. A public key is your wallet address, just like how your public key is an email address. Anyone can access it. But just because someone has your public key, your wallet address, doesn't mean that they have access to your account. The same thing. Just because someone has your email address doesn't mean they have your Gmail account, right? They only have your email address. Okay. Now, if someone is able to access your private key, the same thing. If someone is able to access your Gmail account and password, they'll now be able to access your account with everything, right? It's the same thing. So if someone is able to access your wallet using your private key, they now have entire access to your wallet, and so they can decide to send money. Why can they decide to send money and you can't do anything about it? Because they will sign that transaction using that private key. The same thing, if I have access to Cindy's password and I decide to send money to John and I type in the password, that's it. Because I mean, that's how the system is. Like, you have the password, you have the private key, so send, right? So you always, just like how you guard your passwords, you should always guard your private keys that way, okay? Now Gmail, now she types send, she puts in the password is successful. So Gmail now they sends this mail to the community servers for processing, right? That's what now we call by broadcasting a transaction to the network. P2P means peer-to-peer. So broadcasting this transaction to the network, the P2P network, right? It's the same as Gmail sending a mail to this to everyone who's running the Google servers, okay? So the servers, they process and they deliver the mail. That's how the validation of these transactions work. And then the server which is able to remember, we said the transaction is broadcasted, right? And then we have the consensus mechanisms, okay? So with the consensus mechanism will decide who will be able to process these transactions. So if it's proof of work, you solve a computation, you're able to access a transaction, you solve it, you add it to a block, you get money, right? Because I forgot to add it to the table. Once you click send, there's some sort of transaction fee you pay to send this email, right? And that transaction fee, the server which will be able to process your email, ensure it gets to where it's supposed to go, will receive that transaction fee, right? So Gmail, once they validated that this email is legit, that Cindy has enough money in her wallet, very important. If she's sending in 5 tokens, we're able to ascertain that she has enough money to send these tokens, right? Otherwise, she could be sending ghost tokens, okay? So that's the whole process of validation, okay? It once everything is okay, Gmail adds what? Email to John's inbox. That is now in how I was saying the transaction is included in a block. So what does a block have essentially? It's like you know how you have your email and you have like some sort of metadata for the email, if I can call it, right? So you have the sender email address, which is Cindy at gmail.com. We have the recipient email address, John at gmail.com, right? And then we have the message, which is now the call data. We call it call data in a blockchain, right? So we have the message. The message was, I'm sending 5 tokens to John, right? We have the timestamp. Just like how in email, you'll know this email reached the inbox at 4 p.m. That's the timestamp, right? And then we have a fingerprint that a fingerprint that represents this entire transaction, like a transaction hash, okay? So we now have the hash that represents this, so that if Cindy tries to or let's say if John tries to deny that he did not receive this money, everything is in there, okay? Because it's included in the blockchain, okay? So those are some of the things which are stored in a block, of which we'll be able to still see in real time, okay? Because there's a small program I created some time back, and we can look at that. So they add email to the inbox, and then John opens the inbox and sees the email. It's the same as John's balance is updated, and he has 5 more tokens. Yay! So that's how you can connect, like how Gmail works to how like a transaction lifecycle works in like a general aspect of it in blockchain. And when we continue with this Starknet series, we'll be able to see how a transaction lifecycle works in a Starknet, of which I have another analogy for that. Okay, so but in reality, just the way you can see Gmail, and if you want to remember what the body of a transaction looks like when it's like included in a block, you just remember we have the sender, receiver, timestamp, we have the message, of course we have the header, just like how we have the email headers, we still have the block headers, of which you can still go through that also in your own free time. But yeah, just in simple terms. Now, how do these people agree to the rules of writing to this Google Doc? Because remember, this Google Doc is very important because it's like a record. It's the public record of everything. Okay? So how do they decide which rules are there? Normally, they will have to always come into community calls or community halls, and then they discuss, and then they decide, okay, maybe a message will look like a spam if it looks this way, a thing will look like this if it looks that way. You see all those rules, right? But now let's say they decide to be meeting once a week, but now people are busy, right? Not everyone will be available to always come in for these community halls every day to always ensure that the rules of managing our Google Doc, which is our global blockchain state, is okay. So what do they do? They introduce now what we call smart contracts. Okay, so this smart contracts, it executes, they sort of like feed it the rules, if I can say so. They sort of feed it the rules which need to be accomplished, right? And once you feed these rules, it now executes whatever you want to execute. So that's the same thing as a smart contract, just like how you have like normal contracts, but now with smart contracts, it's now code. It's not like a document, like a physical document or anything. It's now code, whereby you write down the rules which you want. If this happens, then this is supposed to be this way. If we decide this text or this email is a spam, then it does not need to be included in the Google Doc, right? If we decide someone is trying to send money and they don't have any money, then we reverse. You see those sort of rules. So now that's where a smart contract comes in, right? So it executes automatically based on the rules which were written down before. Okay, so that's how smart contracts work in a general level. Okay, so it's actually been a very I hope it hasn't been that long, but those are, I could say, some of the most important aspects of a blockchain, right? Of which we will go through it again if you work to create like a blockchain. Of course, we have other very important things, but these are some of the foundational principles which are needed. And that's how we decided that we created our own decentralized Google, right? So the first thing we decided is the community will host Google by itself by running the community servers. So we introduced the nodes, right? So then the next step was, how do we agree which node will edit this Google Doc? Okay, so we had the consensus models. What are the consensus models? We had the proof of work, proof of ship, proof of history, etc. But always just remember proof of work, proof of stake. Oh my God, I've said proof of ship. Proof of work, proof of stake, right? Sorry. So what if someone is malicious and is trying to join the network? That's why we have the Byzantine fault tolerance mechanisms, right? We want to keep a history of all edits in the Google Doc, meaning if anyone is trying to, once you add something, even if it was by accident to the Google Doc, it's always there, so that we are able to, no one tries to like delete anything without consent of the entire community, right? So we have immutability. Where did this come from? Because remember, our previous Google, they decided to shut down everything, and we couldn't have access to anything, right? So that immutability aspect, that 50, 20, 100 years from now, if I updated my photo to the decentralized Google Photos, it will always be there. Okay, that's the immutability aspect of it. We still want privacy for these photos. I mean, I know there'll be a record which will be recorded in the Google Doc that I have uploaded something, but still, I don't want anyone to know what type of photo I have uploaded, right? That's why we have the hashing. Okay, we want a fair Google Drive. By fair, we mean if you decide to store more, you'll pay more. To avoid a scenario where someone stores more and the rest of the people are suffering because they don't have storage. Remember, storage is limited, right? So we want to ensure a fair system. So store more, pay more. That's gas fees. And then we want to define rules, which will be the rules of a Google Doc. So we'll have smart contracts, right? Yeah. So that's the end of my slides. So that to try and make this information, because it's a bit abstract, to more, let's say, to make it to be a bit more practical, we can, yes. So let me just put myself here. Okay. I hope you can. It's a simple blockchain which I had made some time back using the Rust language, so we can go through it, right? Okay. Okay. Yes. So this is what we were talking about in terms of the blocks, right? When we were saying like a transaction, if it's added to a block. So what type of information does a block have? So when you see here my block, of which its index is 0, so this is what we call a genesis block. Okay. So the timestamp, of course, I haven't put the right format for the timestamp, so forgive me for that. The data, I had coded the data to show it's the first block. It's like the Genesis hash, right? So this hash is what we were talking about, right? So this hash represents, it's like a block hash, okay? So if you try and change anything, if this data, you try and even remove an I, this entire hash will change. Okay? How did we get to this hash? We have this nonce here. A nonce is a number that is used once. Now, to give you more, since already we've talked about this so that you're able to connect. So remember, we were talking about proof of work, right? Whereby these nodes, they compute complex mathematical equations, and then when they compute these equations, the first node to be, or rather the first miner to be able to solve it, has the right to add its transactions to the block. Okay, so this nonce, the way proof of work works is this nonce is like the equation which is being looked for. So you have like an algorithm, right? So I have my data, I have all these details, and I want to look for this current hash. And let's say based on how I designed this system, I put like a difficulty, some sort of difficulty, right? So I said for this hash to be legit, I want it to have the first four zeros. So I set my difficulty to 4. Okay, I want it to have these first four zeros. So what happens is now this server which is running, or let's say if you have a node and it's running this, right, it will start from 0, right? It's like brute forcing, it will start from 0. And then it says the hash generated is not satisfying the requirements which is there. So it will go to 1, 2, 3, 4. So it's doing it repeatedly until it gets to this number which satisfies all the requirements which it defined. And that's when it knows this was the mathematical puzzle that we were trying to solve, right? So that's how nonce works. Exactly. So when you see this, and when you hear we're talking about like solving complex puzzles, right? So let's add another block. Okay, so let's say I want to send money. Sorry, money to John. $5. So we now have our second block, right? So this is the timestamp. Again, forgive me, it's not in the format which we can understand. So this is my transaction here, right? The data which is being stored, or rather the message, right? So it's like I want to send money to John, $5. So as you can see, how are when we say blockchain, how are they linked so that it's immutable, right? You always need to link it to the previous hash of the previous block. That's how you create a chain. Okay, so we have this previous hash, and when you check this other hash, it's different. It's different from this, right? When you check the nonce, it's different still, right? If you see. So let's try something. Hmm. That one has not worked. So I was thinking it would create the current hash, but I'll check that out. Yeah. So I was thinking it would do the same, but it did not work. So like I was trying to say, based on all the messages that you present, every time you present like some data, you will always have what? You will always have like a very if you can see each block has its own nonce, right? So we have for index 0 we have 58 513, we have 63 to 93, we have 35 73, right? So that's how it works. So that's how these blocks link to each other. Okay, so if we were saying this in, let's say, like a Google Doc, it would be this was the first transaction which was recorded, and then it is now linked to the second, because the second transaction will always have the previous hash of the previous transaction, so that you're able to follow through and you have like a systemic flow of how things are working. Okay, so it's the same. So even if I decide to like put empty, because you see my data is empty, it will still be recorded, right? And it will have its own nonce. You can see it's 59 363, right? So let me just, okay, we can do the last one. Let's say 45. So that's how they work. So you have like an index. This is like the block index, and then you have like the timestamp, you have the data, and then you have the current hash, and then you have the previous hash, and then you have the nonce. Now, based on the system, or rather based on the infrastructure, you might have different blocks have different data they're storing, right? Like we'll see later on in the other sessions of Starknet, whereby you can see that Starknet has some specific information that is stored, it stores in its blocks. Okay, and when we get to that, because we'll go through the next session, we'll go through the Starknet architecture. So when we get through that, we'll be able to see how even the transaction life cycle of Starknet looks like. Okay, and we'll go through a Starknet simulator, so you can see things from the mempool stage to the sequencer, to the prover, to the verifier, all these things. Okay, yes, so let me just exit. Okay, yes, so that's just a simple, it's a very simple blockchain system which I had made in Rust, and it uses a proof of work, very simple proof of work system, right? And to create these hashes, I used a Rust crate called SHA-2. So it's like a SHA-2 crate, which I used because that's one of the cryptographic hashing mechanisms you can see, something called SHA-2, SHA-3, etc. So, okay, yeah. That's the end. Thank you so much, guys. I just hope you've been able to understand how blockchain and how most of these blockchain concepts were designed. Thank you so much for following through with me. It's been an awesome, I think it's an hour, right? I hope I haven't bored you. I hope I haven't confused you. In case you have any questions, please feel free to write them in the chat, in the YouTube chat, and also you can reach out through Twitter at Cindy Kamau. And thank you so guys, and have a lovely time ahead. Yes. Thank you so much guys. I just thank you so much for listening through, and I hope I can see you guys to the next session of Starknet series, whereby we'll be looking at the introduction to Starknet architecture. Thanks. Bye. Love you guys.